Hello friends, welcome back to my YouTube channel. This is part number 2 of my discussion on this liquid extraction. In part 1, I had introduced the operation of liquid extraction to you. We understood what is liquid extraction with the help of a simple example. Now in part number 2 on liquid extraction, I will be comparing liquid extraction with other separation methods. And the most important separation method that can be compared with liquid extraction is distillation. So we will understand what is the difference between liquid extraction and distillation, when to select liquid extraction, when to use distillation. We will also compare liquid extraction with chemical separation methods and which are the applications in which liquid extraction is better than those chemical separation methods. We will come to, or you'll come to know at the end of this discussion. So the title that I have given to this discussion is liquid extraction with versus other methods, other separation methods. Let us begin with noting the differences between liquid extraction and distillation. So first we will understand distillation, and then we will compare it with liquid extraction. So if you have to show the distillation operation schematically, you can show it like this. It is carried out in cylindrical vessels in which there are number of trays. Feed is introduced on one of the tray, and then liquid part of the feed, it flows down, it is taken out, it is passed, it is sent to the reboiler where it is heated to create the vapor phase. The vapor phase is then admitted into the column at the bottom. It rises through the column, it is taken out at the top. Then the vapors are condensed by using cooling water. The resulting condensate is divided into two parts. One is taken out as the top product or distillate. The other portion is sent back to the column as reflux. And then after entering the column, the reflux will be joining the liquid part of the feed on the feed plate. So in this way, and then you are taking bottom product out from the reboiler. So if you look at the operation of distillation, you'll come to know that within the column, the two phases, that is liquid phase and vapor phase, they are in contact with each other. But the second phase, I'm talking about the vapor phase. The vapor phase is created out of the liquid phase. And how is that done? That is done in the reboiler. In the reboiler, the liquid phase is heated to create the vapor phase. And when you go to the condenser, cooling water is used to cool the vapor and then to condense them. So in that process, certain heat will be removed. And then the condensate that is obtained, it is divided into two parts. One is sent back to the reflux. We need a pump for pumping reflux into the column. So pumping cost is involved over here. In the condenser, the cost of cooling water is involved. And in the reboiler, cost of heating is involved. So if you talk about distillation, then heating cost in the reboiler and cost of cooling water in the condenser, pumping cost for sending the reflux into the column. So these costs are important. Now let us look at liquid extraction. So in liquid extraction, you have mixer and settler. A combination of mixer and settler makes one stage in that operation. So feed is a liquid solution. It is admitted into the operation, and along with the feed, we use another liquid phase. We call that as solvent. So feed, a liquid solution, is contacted with a solvent, which is another liquid phase, but it is immiscible in the feed solution. So these two liquid phases, they are mixed in the mixer. After proper mixing, the resulting mixture is transferred to another device, which is settler. Here, the mixture is allowed to settle into two phases. Since solvent and the feed solution, they are immiscible with each other, the resulting mixture will be separating into two layers. One layer will be removed as raffinate and the other layer will be removed as extract. Okay, so in the feed solution, for example, there are two components. We will consider a simple case, two components. In this, C is the solute that is to be recovered, whereas A in this case is the carrier solvent. We call that as carrier solvent. Then solvent, the component in the solvent, we are, if we denote that by B, then what happens? The one thing that is important in this case is carrier solvent and the extracting solvent. That is A and B, they are not miscible in each other, or you can say that they are only partially miscible in each other. That is, very little amount of A, or you can say negligible amount of A can get dissolved in B, and negligible amount of B can get dissolved in A. So they are partially miscible. Partially miscible. Only slightly miscible in each other. So what happens when the two solutions, when the two liquid phases, they are mixed thoroughly, the resulting mixture is sent to the settler, which will allow the mixture to settle into two layers. So one is removed as the raffinate layer, whereas the other is removed as the extract layer. And what do you have in the raffinate layer? You have the major part of the raffinate layer will be A. There will be some unextracted solute that may be present in it, and little amount of B that may be getting dissolved in A. Why? Because we have said that A and B, they are partially miscible in each other. And then you can easily tell what will be the components in the extract phase. So major part will be B, then next major component will be the extracted solute, that is C, and little amount of A, the extracted solute, one thing, and the third one will be little amount of A will be going into the extract phase. Why is this happening? Again, answer to this question is A and B, they are only partially miscible in each other. Okay, so if you compare liquid extraction with the distillation operation by looking at these two schematic diagrams for those operations. So we understood in distillation there is cost of heating in the reboiler, cost of cooling water in the condenser, pumping cost for the reflux. Whereas in case of liquid extraction, we are adding the second phase from outside. So there is cost of solvent that is involved. Cost of solvent that is involved. Plus, our aim is to recover C. But what we get at the end of the operation is solution of C. And we need to separate this C. We need to separate C from this solution. And for separating C from B, which is the major component, we have to use distillation. That means in the case of liquid extraction, first we will be using liquid extraction. Let me tell you, liquid extraction is the other name for liquid extraction, and it is also called solvent extraction. So if you are using liquid extraction, then you have to use distillation after that. Then and then only you'll be able to get, you'll be able to recover C. So are you understanding it? So in liquid extraction, you have cost of solvent that is involved. You are adding solvent from the outside. And then after extraction, in order to recover the solute from the extract phase, we will have to use distillation. Okay, so in liquid extraction, we need to use distillation. Okay, so that will make the differences clear to you, differences between distillation and liquid extraction. Now let us write write those points that differentiate the points that will differentiate distillation and liquid extraction. Okay, so as far as distillation is concerned, there is contact of liquid and vapor phases. There is contact of liquid and vapor phases. Whereas in case of liquid extraction, there is contact of two insoluble liquid phases. So contact of liquid and vapor, which are not soluble in each other, and in the case of liquid extraction, there is contact of two insoluble liquid phases. Then for distillation, the vapor phase is created out of the liquid phase. So even if the feed is partially vaporized, that means it is both liquid and vapor phases are present in the feed. Still, liquid phase is boiled in the deboiler to create the vapor phase. So that's why we are saying that in the case of distillation, the vapor phase is created out of the liquid phase. Whereas in the case of liquid extraction, the second liquid phase, which is the solvent, it is added from outside. And we are adding the second liquid phase as the extracting solvent. Then, in the case of distillation, vapor and liquid phases contain same components. So, for example, if you have a liquid solution containing A and B in it, and if you heat it and create the vapor phase, the resulting vapor phase will also be containing the same components. So no new component will come into picture in the case of distillation. So that's why I'm saying vapor and liquid phases both contain same components. Whereas in the case of liquid extraction, the two liquid phases, that is the feed solution and the solvent that is used for extraction, they are chemically different. The two liquid phases are chemically different. Then in the case of distillation, the difference in the boiling points of the components is used as is the basis for separation. In distillation, the components of the liquid solution, they are separated on the basis of differences in their boiling points. Whereas in the case of liquid extraction, the difference in physical and chemical properties of the components is utilized or is the basis of separation. The basis of separation in the case of liquid extraction is a difference in physical properties of the components involved. Then in the case of distillation produces almost pure products. That is, distillate will be pure distillate. It may be containing 99% of it. The purity may be up to 99%. Same is the case with bottom product. The purity may be up to 99%. So the point is, distillation, it produces almost pure products. Whereas in liquid extraction, products are solutions. So you get raffinate phase, which is a solution. You get extract phase, which is again a solution. So products are not pure components. They are solutions. Then in the case of distillation, cost of heating in the reboiler and cost of cooling water, they are involved. Whereas in the case of liquid extraction, cost of solvent is involved. In distillation, there is no need of further purification, whereas in the case of liquid extraction, the solute must be separated from the extract phase, and for that we need to use another separation method, and most of the time the separation method that is used is distillation. Okay, so all these points will tell you how distillation and liquid extraction are separate from are different from each other. Distillation, it has its own uniqueness. Liquid extraction, it has its own uniqueness. So depending on the conditions, you need to select either distillation or liquid extraction. Let me tell you, if distillation is not feasible, then the most popular choice is liquid extraction. So people will first try to use distillation, and then if it is not feasible, then they will go for using liquid extraction. But most of the time, in most cases, distillation is preferred, even though costs of heating and cooling are involved. But there are some applications where liquid extraction is better than distillation. We are going to discuss those applications. And there are some applications where only liquid extraction can be used. So we will come to know about it. I hope you have understood the differences. So if somebody asks you to differentiate between distillation and liquid extraction, you can write all these points. So you have 1, 2, 3, 4, 5, 6 and 7 points that will help you in differentiating between liquid extraction and distillation. Now, first thing is, if you have a choice, that is to be choice of selecting either distillation or liquid extraction, then what will you do? Let us understand. So, if there is a choice, both can be selected, then distillation is always selected. If you have applications where either distillation can be used or liquid extraction can be used, so if that is the case, the popular choice is distillation. Distillation is always selected, where both distillation and liquid extraction can be used. Why? And this is true. That means distillation is selected even though it requires heating and cooling. Why? Let us understand. In liquid extraction, you have this operation, you are getting feed is contacted with the solvent phase, and at the end of the operation, you are getting raffinate and extract phase. Extract phase contains the solute. We need to recover that. For that, this extract phase is subjected to distillation. It is sent as a feed to a distillation column, and then you'll be getting the solute separated from this extract phase. That means after liquid extraction, we need to use distillation. So you have cost of solvent, and then we also have to use distillation, or we need to use some separation method to get solute out of this extract phase, and the most popular separation method is distillation. Okay, so that's why in extraction we need external solvent, and after extraction the solvent needs to be recovered. So recovered, and how you are going to recover that? By separating the extracted solute. So when you subject extract phase to distillation, you are recovering the solute, plus you are also recovering the solvent, so that you can use the solvent in the next extraction operation. So that's why I'm saying after extraction the solvent needs to be recovered. How are you going to do that? By separating from the extracted solute, and distillation is often used for this separation. And that means in liquid extraction, we need to use two operations. There is a combination of extraction and liquid extraction. And this combined operation is more complicated, and most of the time it is more expensive than distillation. So even though distillation involves heating cost and cost of cooling water, but in liquid extraction, the combined operation, extraction and distillation, the combined operation is complicated, one thing, and it is also expensive. So that's why if there is a choice to be made between distillation and liquid extraction, distillation is the most popular choice. I hope this is clear to you. So if you have to select between distillation and liquid extraction, where both can be used, then you always select distillation. Okay. Then let us look at some applications where liquid extraction is better than distillation. There are few applications where you'll find that liquid extraction is better than distillation. So when is this true? In case of dilute aqueous solutions, where major component is water, plus when water is the more volatile component, that means you need to vaporize water. So in those applications, in applications where components are to be separated from dilute aqueous solution and water is the more volatile component. So in these cases, you'll find that liquid extraction is better than distillation. So if you try to use distillation for this dilute aqueous solutions, what is required? You need to vaporize water. Water needs to be vaporized. And as water has high molar latent heat of vaporization, the heating cost is more. So in the case of dilute aqueous solutions, where you are separating water as the more volatile component, then you need to vaporize large quantity of water. And as water has high molar latent heat of vaporization, the heating cost is more. If you use liquid extraction in this case, what advantages do you have? The solute can be separated by extracting it with a suitable organic solvent. So you choose a suitable organic solvent to extract solute from aqueous solution. And the organic solvent you can recover if since we have to use distillation after extraction, where you need to vaporize organic solvent, and organic solvents have low molar latent heat of vaporization, therefore they can be easily recovered. The organic solvent then can be recovered by distillation. So it is less costly to vaporize the organic solvent. So that's why this liquid extraction is more, you can say it is cheap as compared to distillation. Because in distillation you need to vaporize water. Water has high molar latent heat of vaporization, so heating cost is more. So if you use liquid extraction, and for that, if you use a suitable organic solvent, which you can easily recover by distillation, it would be less costly to vaporize the organic solvent. So in this case, liquid extraction is better than distillation. So if you want to know about specific example, for example, acetic acid, it can be separated from its dilute aqueous solution by using extraction, by extracting it into a suitable organic solvent. So when components from dilute aqueous solutions are to be separated, and when water is the more volatile component, then liquid extraction is a better choice. Then another example, in the case of high boiling or heat sensitive components. So in the case of high boiling components and in the case of heat sensitive components, you'll find that liquid extraction is better than distillation. Let us understand how. Now, what are these high boiling components? High boiling components, they have high boiling points. That's why we are calling them as high boiling components. And as far as heat sensitive components are concerned, these heat sensitive components, they can get thermally degraded even at normal distillation temperatures. So even if you carry out distillation under normal conditions at normal temperatures, even though there are some components which we call them as heat sensitive components, these heat sensitive components will be thermally degraded. They will lose their properties at higher temperatures, even at normal distillation temperatures. So if you use distillation at atmospheric pressure for this task of separation, what is the case? In the case of high boiling points, the heating cost will be high because you need to heat them to a higher temperature because they have high boiling, their boiling point is high. So if you carry out distillation at atmospheric pressure, heating cost will be more because you need to heat to relatively higher temperatures. And in the case of heat sensitive components, what can happen at atmospheric pressure? They may get thermally degraded. So what is the option? What is the other option that can be used? So you can carry out distillation at reduced pressures. We call that as vacuum distillation. Distillation at subatmospheric pressures. So in the case of high boiling components, their boiling point will be reduced. They will boil at lower temperatures. So that is the advantage with high boiling components. If you carry out vacuum distillation, then they will boil at lower temperatures. The heat sensitive components will also boil at lower temperatures, but in some cases, even at these lower temperatures, they may get thermally depleted. And in the case of high boiling components, in vacuum distillation, even though they boil at lower temperatures, the cost involved is more. So in these cases, in the case of vacuum distillation, it may not always be economical choice. So for that, you can go for liquid extraction. So for example, if you have to separate long chain fatty acids from vegetable oils, it is more economical to do that by liquid extraction. So you can use liquid extraction with liquid propane as the solvent. So the point is, the application where liquid extraction is better than distillation. What is the second application? The second application is separation of high boiling components and separation of heat sensitive components. You can use vacuum distillation, but vacuum distillation may not always be the economical choice. The heat sensitive components may get thermally degraded even at lower temperatures. Some heat sensitive components. So in those cases, the better choice is liquid extraction. The best example is you can separate long chain fatty acids from vegetable oils by liquid extraction with liquid propane as the extracting solvent. So I hope now you know where liquid extraction is better than distillation. First was separation of components from dilute aqueous solutions, and the second application is separation of high boiling components and separation of heat sensitive components. So you can summarize. Distillation is a better choice in the following cases. When heat requirement in distillation is very high, that is in the case of aqueous solutions. When the liquid solution contains close boiling components, that means there is no much difference between the boiling points, then distillation will not be used. You cannot use it in that case. So you can go for liquid extraction. When heating needs to be avoided, so this is the case with heat sensitive components, which can get thermally degraded at even relatively low temperatures. So in that case, you can go for liquid extraction. When components to be separated are of quite different nature. So if components to be separated are of quite different natures, then also you can choose liquid extraction over distillation. So these are the applications where you can say that liquid extraction is a better choice. When heat requirement in distillation is very high, when the liquid solution contains close boiling components, when heating needs to be avoided, as in the case of heat sensitive components, and when the components to be separated are of quite different nature. Okay, now let us look at those applications where extraction can be used as a substitute for chemical methods. So which are these applications? What are these chemical methods? These chemical methods are used for separation. And what are the facts with these chemical methods? The first thing is we need chemical reagents. For chemical separations, we need chemical reagents, because in those methods chemical reactions will be involved, and for that we need chemical reagents. Chemical methods, they produce byproducts, and we need to dispose this byproducts. So there is a frequent need of disposal of this byproducts, which is costly. So the disposal is expensive. So in comparison to this, let us now understand liquid extraction as a substitute for this chemical methods. So chemical methods, if you use, we need chemical reagents, because chemical reagents will be consumed. Many chemical byproducts may be produced, and these byproducts should be disposed of, and this disposal is expensive. So if you use liquid extraction as a substitute, then what are the advantages? There is no chemical reagent required. We don't need any chemical reagent. There are no byproducts, because there is no any chemical reaction in liquid extraction. So no byproducts are formed. And if there are no byproducts, there is no question of disposing them. They can substitute in this liquid extraction can substitute chemical methods in metal separations. For example, separation of uranium, vanadium, separation of hafnium, zirconium, and separation of tungsten, molybdenum. So in this separation applications, you can replace chemical methods with liquid extraction. Then liquid extraction can also substitute in separation of products of atomic energy processes. So the products produced during various atomic energy processes, they can be easily separated. They can be more economically separated by using liquid extraction. Then liquid extraction can substitute in purification of copper, metals like copper. Then liquid extraction can substitute in purification of various chemicals like phosphoric acid, then boric acid. So these were the advantages, or where you can substitute chemical methods with liquid extraction. Now let us understand few examples where you can use only liquid extraction. No other separation method can be used. Which are these examples? For example, when you have solution of components with nearly same boiling points, so you cannot use distillation, because separation will never be achieved in that case, as the components will be having nearly same boiling points. So separation not possible by distillation, but liquid extraction, it can be used with appropriate solvent. While selecting solvent, you can take care of this. A solvent with chemical nature that is similar to the solute to be separated. it will give better result. For example, if your aim is to separate if you have a feed solution that is containing A and C and your aim is to separate C, then you can choose a solvent, for example B, whose chemical nature is similar to that of C. So if that is done, then you are going to get better results. Extraction will be, the E extraction, percentage extraction will increase in this case. For example, separation of aromatic and paraffinic hydrocarbons you can do by liquid extraction. So if you try to use distillation for them, separation by distillation is not possible because they are close boiling components. Separation by liquid extraction is the choice in this case. You have different solvents that you can select from. So you have liquid sulfur dioxide can be used, diethylene glycol can be used, or sulfolane can be used as solvent. The other option available is extractive distillation. So for this separation task, separation of aromatic and paraffinic hydrocarbons, you can go for extractive distillation. But extractive distillation is nothing but extraction from the vapor phase by using a solvent, and this is not liquid extraction. In this case, we are talking about liquid extraction. Are you understanding it? So, other option for this separation is extractive distillation, but extractive distillation is extraction from the vapor phase by using a solvent. It is different from liquid extraction or liquid extraction or solvent extraction, which is extraction from the liquid phase. So, extractive distillation is extraction from the vapor phase, and liquid extraction is extraction from the liquid phase. You can remember this difference. Then pharmaceutical products like penicillin. This penicillin, it is produced in complex mixtures, and the only way of separating from such complex mixtures is extraction, liquid. So in that case also you can use liquid extraction. Then separation of aromatics from catalytic reformate. So the catalytic reformate that is formed, you have a task of separating aromatics from the catalytic reformate. The only choice available to you is liquid extraction. So aromatic hydrocarbons like benzene, toluene, and xylene, they can be separated by using liquid extraction. The solvent used, the most popular solvent is sulfolane, which you can use in this extraction task. What are the reasons? It has high selectivity for aromatics and it has low volatility. So in this way, I'll end my discussion for this topic. So here I had tried to tell you difference between liquid extraction and other separation methods. If you have a choice between distillation and liquid extraction, then you can go for distillation. Then there are some applications where liquid extraction is better than distillation. There are some applications where liquid extraction can be used as a substitute for chemical separation methods. And then I also discuss those applications where you can use only liquid extraction. So with this, I end my discussion for this particular video. I hope now you will be able to tell what is the difference between liquid extraction and distillation, how to select, how to make a choice from distillation and liquid extraction, in which applications liquid extraction would be a better choice, in which application liquid extraction can be used as a substitute for chemical separation methods, and in which applications liquid extraction is the only choice. So with this, I end my discussion for this particular video. Thanks for watching my video. Please do subscribe to my channel. Tell your friends to subscribe to it. In my next video, I'll be discussing another aspect of liquid extraction. For now, thank you. And I am sure that you'll join me in my next video. For now, have a nice day. Bye.